Hi guys, now we are going to discuss about the building decision support system. That is how the companies are developing a decision making supporting system for making decisions. So building a decision support system will accessing all information assets including legacy and relational data sources. That is nothing but you are what are the failures of the old products, or what are the designs of the new product, what are the sources they are having, what are the resource people they are having. So every access or every assets information will be there, and comparative data figures it has to produce. That is nothing but, so whatever the analysis they are doing, it has to provide in figures. So for the easy understanding, for easily for making the decision by the decision makers, and projected figures based on the new data or assumption. That means what will be the benefit. So those things we can able to project by various data they are having, and consequences of different decision alternatives given past experience in a specific contents. Suppose for making any decision in previous, or any failures are happened, or how it is happened, when it is happened. So those data it will be useful for making a new decision for the new product. So by this we can able to increase the profit, and we can reduce the losses. That means the repetitive mistakes won't be happen. So we need external and internal data. Otherwise, other than that, we need computer based systems, and we need data management and various model management. That is nothing but what the different types of models are available for making the decision. So that one. So based on that, the knowledge management will be there, and user interface will be there with the decision makers. So these are the data will be useful for making the decision for a new product. And now we are going to discuss about the model management system. That is what are the different types of models available for making a decision. So first one is your statistical model. That means data and figures, so that will come into the statistical. And sensitivity analysis, that means why it is going to fail, or like that, the sensitive factors it has to identify. And optimization analysis model, that means optimization of the product, what are the factors we have to consider, so those things. And forecasting model, that is nothing but your vision, or in future what is going to happen. So by that the prediction we can able to do by the forecasting models. And backward analysis and sensitive model. So these are the various models for your model management system. And now we are going to discuss about the characteristics of Dssrd. So an ideal decision support system should not be used to make automatic decision. Instead of assist and encourage people in effective decision making system. That is your DSS should not this solution you have to take like that. It has to support the people, or the decision makers as to this decision, if you are taking this much profit will come, like that it has to support. And it must provide a support for both individual and a group of decision maker. That means the CEO may be the decision maker, or the research people will be the decision maker. So it should support them, and it must present information to the customer in a way easy to understand. That means easily the customer has to accept or can understand. So that way the information should be there. That means in layman language the information should be there for making the decision. Must have the programming capability to generate many types of reports, all based on the user specification. That means depends upon the customer requirements, it has to produce the report. Depends upon various certification, various sort of reports are required. So for like that it has to produce. It must include variant types of models, and a good DSS should be able to respond quickly to changing the needs of decision makers. So with respect to the decision makers, whatever the prediction they are making at the stipulated time it has to give. So it should not take too much of time. So like that. So it should be a very user friendly to the decision makers, and it must be intended for a repeated and routine use. This enabled through a quantitative analysis is very short time, and even frequent changes in the scenario can be evaluated objectively in timely manner. Data collection and model construction experiments are executed with active user participation, thereby greatly facilitating communication among managers. Now we are going to discuss about the limitation of your DSS. So even though your DSS may quantify some of these aspects, the end of the results must be based on the own judgment of the decision maker. That means the DSS system won't make decision. The head or the research people head will take the decision makers. A computerized DSS may sometimes result in information overload, which major problem for people involved in decision making. That means if you are having too much of information, it will make a confusion only. If the decision maker is very clear, easily he can able to take the failures and then he can make a decision. Otherwise, it will confuse sometimes for the decision making. Building DSS is often very expensive and complex because people vary so much in terms of their personalities, knowledge and ability, preferences, the job they hold and the decision they need to make. So depends upon the people and depends upon the cost, it will be very high, and it provide all information in the form of graphs, pictures or text without much emphasis on facts. Various type of DSS are communication driven DSS, data driven DSS, document driven DSS, knowledge driven DSS and model driven DSS. Now I am going to play a small video for your better understanding.
Now more than ever, bottlers in the beverage industry must be able to respond to market demands with great flexibility.
Hi, how are you doing? Fine, thank you, thank you. How much beer do you need? 100 barrels of beer. Okay. Until Friday. Okay. Hold on a minute.
For example, if an additional order comes in, you often have to decide very quickly whether it's feasible to take it on. For that, you'll need to keep many factors in mind. How many other orders have we got? Do we have enough inventory? And do we have enough time for an extra bottling run? Those are the obvious questions. There are many other less obvious questions that are at least as important. What is the availability of the lines? Are any servicing or maintenance tasks scheduled? Are any downtimes foreseeable? Do we have the people we need to complete the job? Is anyone out on vacation or sick leave? Will shift schedules and labor laws allow for another order? What about storage and shipping capacities? How are sales trending? And last but not least, cost. Can I do the run at the usual price, or will I have to add a surcharge? All of these factors must be considered as a whole in order to arrive at the right decision for your business. Dssrd develops digitalization solutions which will give you a sound basis for making those decisions in the near future. Dashboards based on a variety of parameters give you a clear view of your ongoing production and enable you to predict how things are likely to develop. So you can make sound decisions that provide planning security and can be reproduced in the future.
No problem, we can do it. Thank you, bye, bye.
Dssrd, your partner for digitalization.
Imagine a nuclear incident anywhere in the world. Imagine, rather than leading to global disorder, the decision support system for nuclear emergencies affecting food and agriculture, better known as DSS for NAFA, springs to life. It sets up sampling plan, it navigates sampling in the field, collects data from field and laboratory, processes data, and visualizes decision support options. And this is how it does it. Immediately, it downloads and analyzes data on known radiation contamination rates, and within minutes gives decision makers a range of precautionary options for protecting food and agriculture. At the same time, it computes what additional data will be needed to inform decisions that will keep the population safe. It combines land use maps and crop calendars with sampling protocols for each type of crop and vegetation in potentially affected areas. And by using pre-established sampling grids, instantly creates detailed assignments to guide sample collection teams in the areas. The geolocation of its mobile app even registers sample positions and adjusts the grid if they are taken off position. And at the same time, sample collectors provide additional information directly from the field via their mobile. The samples are then analysed in pre-selected laboratories that are also linked to DSS for NAFA. And the results of each sample are recorded directly into the system. DSS for NAFA now contains all the information it needs to generate visuals, easily comprehensible maps of the data superimposed over geographic and land use maps. Using innovative computer algorithms and geovisualization platforms, the information is shown without overcrowding the map, even ranking according to significance. Decision makers can even generate interactive queries, for example about the rate of contamination in space and time. The continuously evolving situation is visible at a glance on tablets or screens, and at scales from field level to national and international level. And with all of this, it requires minimal training to use it effectively. And while decision makers use this information to formulate up-to-the-minute guidance with regard to agricultural production or food consumption restrictions based on national regulations, political specificities and actual data, DSS for NAFA is already providing support on subsequent sampling assignments and continues the data acquisition process so that authorities are always presented with the latest and most up-to-date decision support. Imagine DSF for NAFA doesn't exist. Imagine it does.